Hello. In this lecture we will start talking about IKE version 2. IKE version 2 was introduced in 2005 by Microsoft in RFC 4306. The main Mode 6 messages are condensed into 4 messages. The first 2 messages are used for initialization. The first 2 messages are referred to as IKE initialization. The second 2 messages are used for authentication or IKE auth. Now the IKE version 2 preempts the process by generating a Diffie-Hellman key from the get-go. This gets sent to the responder. There is a likely possibility that the responder doesn't support the Diffie-Hellman key. In that case, the responder will send a notify message indicating the Diffie-Hellman key is invalid. That message is a notify message of type invalid key payload. In the event this happens, the responder will respond with a notify message of type invalid key payload. This will inform the initiator to send a different Diffie-Hellman key of group 1, in this example. So, even though IKE version 2 reduces the number of messages to 4, there are potential for messages to increase as with this scenario. In the event that the responder supports that Diffie-Hellman key, then the session progresses into the authentication stage. After the responder receives the first message, it has everything to compute the shared master key, the seed key, as well as hashing, encryption, and phase 2 keys. When the initiator gets message 2, it can also do the same. Message 2 also can contain a certificate request, that is if the responder supports certificate authentication. So, now that both sides are able to communicate securely, the initiator will send an authentication request. This is message 3 here. This message contains multiple pieces of information. The ID of initiator lets the remote side know what ID the initiator is using. So this field would contain IP address in the case of pre-shared keys, or the subject common name of the certificate that is used. If certificate authentication is in use, the initiator will send its own public cert. It will also tell the responder that it supports certificates issued by the following list of certificate of authorities. This is a list of certificate of authorities that it trusts. This is listed in the cert request field. The initiator then needs to prove it knows the private key by encrypting a portion of the first message it sent in the communication. That is IKE message 1. Now, there is also more information packed in this message. Also, the phase 2 negotiation gets triggered. This is by the initiator specifying the security association for phase 2 or what encryption, hashing, and Diffie-Hellman key it supports. The Diffie-Hellman key in case PFS is in use. It also sends network A and network B. However, in IKE version 2 this is referred to as traffic selectors. It sends traffic selector initiator and responder, or which networks are on this side and the other side of the connection that will be tunneled. As you can see, this compresses a lot of the information into less number of messages. Another difference between this version and version 1 is the fact that we are not creating a hash initiator or hash responder. Authentication encrypts message 1 or message 2 to prove the knowledge of the secret. Message 1 is encrypted by the initiator while message 2 is encrypted by the responder. The secret can be either a pre-shared key or a certificate private key. The responder also proves its identity by authenticating the second message. Also, hash responder is not used like in the case of IKEv version 1. The responder also sends its ID and certificate. It also sends the security association for phase 2, which means what encryption hashing and PFS key will be used. It will also send the traffic that will be protected by the tunnel, which is traffic selector, initiator and responder. We will discuss more in the next lecture.